Hello there, and welcome to the Silent Skies. Settle in for a moment and allow your mind to drift back, not to the last few centuries of our own human story, but to the eons that preceded us. A staggering, bewildering length of time when this planet was an altogether different place. We often imagine that if an ancient civilization existed, it would be a mirror of our own, a society of warm-blooded, tool-using bipeds, leaving behind rusted metal and crumbling stone like us. What if we were looking in the wrong direction? What if the story of Earth's first architects was written not in the frantic heat of industry, but in the patient, sun-drenched silence of an entirely different metabolism? What if the first brilliant minds on this planet were cold-blooded? Imagine a different dawn. Not the dawn of humanity, but of something else. Something reptilian. Imagine a world where the colossal reptiles of the Mesozoic didn't just survive the great extinction events, but thrived. Not by chance, but through a cunning, collective intelligence we've yet to properly appreciate. These were not the lumbering beasts of our imagination, but creatures whose existence was a masterclass in energy efficiency. Their needs were minimal, their pace deliberate, their understanding of the world a gradual, patient accrual of knowledge over millennia. They were thinkers in deep time, their very physiology dictating a different kind of progress. Before we venture deeper, I want to know the particular moment you've chosen for listening, and what time is it where you're from? Are you surrounded by the soft darkness that makes everything feel more intimate? In whatever time and place you find yourself, we're connected here through this shared curiosity about things we can't always touch or see. If this kind of gentle exploration resonates with you, thoughtful without being rushed, curious without demanding answers, I'd be deeply grateful if you'd like this episode or share it with someone who might appreciate these quiet moments of reflection. These small acts of connection help these conversations reach others who might be searching for this same gentle companionship. It's like leaving breadcrumbs for kindred spirits. Picture their society. There would be no frantic rush to build, no clamor for constant innovation fueled by an insatiable need for energy. A cold-blooded civilization would build with purpose and with a profound respect for the sun, their ultimate power source. They would be masters of thermal dynamics. Instead of burning fossil fuels to generate heat and light, their cities would be sculpted landscapes designed to capture and regulate solar energy. Their architecture might be a symbiotic extension of the Earth itself, with vast, flat surfaces of dark stone acting as solar panels and complex underground tunnels providing a cool, stable environment for their young and their elders. It would be a technology of stillness, of patience, of absolute efficiency. Their inventions would reflect this. We might look for metal cogs in steam engines and find only rubbish. Their technology would not have been mechanical, but biological. They would have engineered organisms to do the work of machines. Plants that could filter pollutants from the air, fungi that could break down waste, and genetically modified insects that could carry information or build structures with their own bodies. Their tools would be living things, their communication networks a biological hive mind. They would have had no need to split atoms for power, for the very planet provided all they needed, as long as they were clever enough to harness it. Their understanding of biology would be so profound that they could manipulate life itself on a grand scale, perhaps to alter their own forms for specific tasks or to create entire ecosystems to serve their needs. This wasn't a world of explosions and noise, but of silent, creeping change. They wouldn't have built vast, noisy factories or rushed to cover the world in concrete. Their progress would have been a slow, deliberate bloom. Their society, a grand, collective artwork sculpted over millions of years. Their greatest fear would not be the darkness of night, but the sun-blocking cloud of a volcanic winter, a truly existential threat to their very existence. And in that, perhaps, lies the answer to their disappearance. Their entire civilization, so perfectly attuned to the sun, might have been undone by a single catastrophic cooling event, leaving behind only the most subtle of traces. Could those strange, perfectly geometric rock formations in the deserts of South America be the remains of their solar collectors? Could the unexplained global changes in certain plant species in the fossil record be the biological remnants of their terraforming efforts? We are so used to seeing the world through our own lens that we might have completely missed the evidence, looking for what we would have built, rather than what an altogether different kind of intelligence would have left behind. Their legacy is not in the grand structures we seek, but in the quiet, chemical fingerprints left across the earth, waiting for a different kind of scientist to come along and read them. The most difficult part of this thought experiment is not imagining their existence, but imagining their absence. When we humans vanish, we will leave behind a legacy of concrete, plastic, and radio waves, a record so dense that future archaeologists will have a veritable feast of data to sift through. Our cities will crumble into recognizable ruins, our landfills will preserve synthetic materials for millennia, and our nuclear waste will glow with radioactive testimony to our technological prowess. But a cold-blooded civilization, one that lives in a state of energy-saving grace, would leave a different kind of archive, one written in a language we are only just beginning to decipher. It's the language of geology itself, the subtle shifts and hidden clues buried deep within the Earth's crust. Consider the notion of a technosignature. We look for things that an advanced civilization would leave behind, giant structures, persistent chemical pollutants, or even orbital debris. Our SETI programs scan for radio signals, our telescopes search for Dyson spheres, and our probes seek out the atmospheric chemistry of distant worlds. But what would a civilization that valued efficiency and subtlety leave? Their buildings would not be made of concrete and steel, but perhaps of biomineralized structures grown in place, designed to eventually decompose back into the earth. Imagine coral-like constructions that could self-repair and ultimately dissolve into calcium carbonate deposits indistinguishable from natural formations. Their tools would be living organisms that, once their purpose was served, would simply die and leave behind a faint genetic trace, if any. The very things that make them so intriguing also make them almost impossible to find with our current methods.
Their energy systems might have been based on biological fuel cells or atmospheric processes that operated at ambient temperatures, leaving no thermal signatures. Where we build power plants and dams, they might have cultivated vast networks of engineered bacteria that processed methane or fixed nitrogen with unprecedented efficiency. These living power grids would have pulsed through the Earth itself, drawing energy from geothermal sources through biological intermediaries that enhanced natural processes rather than replacing them. The traces we should be looking for are not the grandiose, but the microscopic. Instead of searching for pyramids, we should be looking for a slight, unnatural change in the isotopic composition of carbon in a particular geological layer. A subtle shift that suggests a large-scale, prolonged biological process that had no natural explanation. Or perhaps a sudden, unexplained spike in the presence of synthetic polymers that have a unique, non-biological signature, a forgotten legacy of their biological engineering. We might find unusual concentrations of rare earth elements in patterns that don't match any known geological process, or discover fossil evidence of organisms with impossibly complex internal structures that could only have been designed. We're talking about things so subtle that our own science is only now capable of even detecting them. Advanced mass spectrometry can identify molecular signatures down to parts per billion. New techniques in paleogenomics allow us to extract and analyze ancient DNA from sediment cores. But even with these tools, we might be looking right past evidence of their existence because we don't recognize the patterns they would have left behind. Think of it this way. Their society would not have left behind a booming, noisy city, but a quiet, living ecosystem, a self-sustaining system of living technologies that, when they finally died out, would leave behind only a faint echo in the geological record. Their transportation networks might have been biological, engineered fungi creating underground mycelial highways, modified route systems that could transport materials across continents at the speed of chemical signals. Their manufacturing could have been entirely enzymatic, producing materials through biological processes that left no industrial waste, only organic byproducts that fed back into natural cycles.
It would be like trying to find a whisper in a hurricane. You'd need incredibly sensitive equipment and a very specific idea of what you are listening for. We have to learn to stop looking for our own reflection in the past and start looking for something entirely alien. Their footprint would not be in the form of a crater or a ruin, but in the most delicate of all archives, the very chemistry of the Earth itself. Perhaps in anomalous oxygen isotope ratios that suggest massive biological oxygen production beyond what natural photosynthesis could account for, maybe in trace elements distributed in patterns that mirror no known mineral formation or biological process. The ultimate irony is that their greatest achievements might appear to us as perfectly natural phenomena. What we interpret as unusually efficient ecosystems or remarkably stable geological formations could be the carefully engineered remnants of their civilization. Their greatest cities might look like pristine forests, their highways like river valleys, their factories like coral reefs.
It's a humbling thought, isn't it? To consider that a civilization of immense intellect and complexity could have come and gone, their rise and fall leaving behind nothing more than a few faint lines in the sand of time. We might be living on top of their legacy right now, completely unaware, because we were searching for the wrong thing all along. Perhaps the very stability of our planet's climate, the remarkable diversity of life, or the peculiar efficiency of certain ecosystems are not accidents of evolution, but the still functioning remnants of their ultimate gift to the world, a biosphere engineered to sustain life long after its creators had returned to the Earth from which they came. The very air we breathe today, with its specific blend of nitrogen, oxygen, and trace gases, is a product of our planet's long and tumultuous history. Every molecule tells a story of ancient volcanic eruptions that belched sulfur into the stratosphere, of vast oceans of cyanobacteria that first split water molecules and flooded the atmosphere with oxygen, of ice ages that locked away carbon in glacial ice, and of the slow dance between rock and sea that has regulated our planet's thermostat for billions of years. It is a record of everything that has lived, died, and transformed on the Earth's surface. And for our cold-blooded civilization, the atmosphere would have been both a source of life and a ticking clock. Unlike us, who exhale carbon dioxide as a byproduct of our internal furnaces, burning glucose at a steady rate regardless of the weather outside, a cold-blooded species would have had a different relationship with the carbon cycle. Their respiration would have been slow, deliberate, and directly tied to the ambient temperature. In the cool of dawn, their metabolic processes would have nearly stopped, each breath stretched out like a meditation. As the sun climbed and warmed their world, their thoughts would have quickened, their chemistry accelerated, their very consciousness ebbing and flowing with the thermal rhythms of their planet.
But if they had achieved a high-level technological society, they would have inevitably interacted with the carbon cycle on a planetary scale. Their relationship with atmospheric chemistry would have been intimate and sophisticated in ways we can barely fathom. They might not have burned fossil fuels for energy, but perhaps they would have needed to manipulate global temperatures to better suit their needs. Consider the profound implications. A species whose intelligence itself was temperature-dependent would have had every incentive to engineer optimal thermal conditions across their world. Imagine a world where their intelligence led them to a grand planetary-scale project, terraforming the globe to create more favorable climates for their kind. This might involve a subtle, slow-burning process of releasing specific gases to trap more solar energy, carefully calibrating the greenhouse effect to warm polar regions and moderate seasonal extremes. Or perhaps the planting of immense, specially engineered forests to alter weather patterns, vast networks of modified trees that could influence rainfall patterns, regulate humidity, and create thermal corridors that channeled warm air to previously uninhabitable regions. Their atmospheric manipulation might have been breathtakingly sophisticated. They could have deployed stratospheric aerosol injection systems using biological processes, releasing precisely calculated amounts of reflective particles during periods when cooling was needed. They might have engineered massive algal blooms in the oceans, timed to absorb carbon dioxide during global warming periods, then allowed these organisms to die and sequester carbon in deep ocean sediments. This wouldn't be a sudden, catastrophic change like our own industrial revolution, but a gradual, deliberate shift over thousands of years. Where our impact on the atmosphere reads like a violent punctuation mark in the geological record, theirs would appear as elegant penmanship, each stroke carefully planned and executed. The smoking gun, the evidence of their existence, wouldn't be a sudden spike in a geological layer, but a gentle, almost imperceptible curve in the carbon or oxygen isotope ratios, a curve that our current models of natural planetary cycles cannot explain. These curves might reveal themselves in ice core data as unexplained oscillations in atmospheric composition that don't match any known natural cycles. We might find evidence in the ratios of carbon-12 to carbon-13 that suggest massive biological processes operating at scales and with timing that nature alone could not achieve. The fingerprints of their atmospheric engineering might appear as subtle but persistent deviations in the normal patterns of seasonal carbon exchange between atmosphere and biosphere. Perhaps most intriguingly, their influence on the carbon cycle might still be active. The current stability of our climate, the remarkable self-regulation of atmospheric composition that has kept Earth habitable for billions of years, might not be entirely natural. The Gaia hypothesis suggests our planet functions as a self-regulating system. But what if that system had help? What if the negative feedback loops that keep our atmosphere stable were enhanced or installed by a civilization that understood the delicate balance required for long-term planetary habitability? It is a sobering thought that the very air we take for granted, the very breath in our lungs, might carry the faint, ghostly echo of a civilization that came and went long ago. Each inhalation might contain molecules that were once processed by their atmospheric engineering systems, carbon atoms that were sequestered and released according to their grand design. We are, in a way, breathing their history, and yet we are completely blind to it. It's like trying to listen to a full symphony, but only being able to hear the quietest notes of the string section. We miss the main melody because we are not attuned to the frequency of their existence. The planet holds their secret, and it's a secret that we're only now, with our most advanced scientific tools, beginning to hear. Our atmospheric monitoring stations, our satellite measurements, our deep ice drilling projects, all of these might be detecting the remnants of their work without recognizing it. We must learn to listen not for the loudest noise, but for the most subtle of whispers embedded in the very chemistry of our world. A cold-blooded civilization would face a unique challenge in preserving its history. For us, a stable internal temperature allows for a constant, reliable metabolism. Our brains are always on, running at a steady 37 degrees Celsius, our neural networks firing with mechanical precision regardless of whether we stand in Arctic winds or tropical heat. Our memories are stored in a relatively consistent state, encoded in synaptic connections that remain stable across decades of our lives. We have been able to build libraries and create vast digital archives because we are not dependent on external conditions for our cognitive function. Our memory is a constant flame, burning steadily from birth until death, allowing us to accumulate knowledge, build upon previous discoveries, and create civilizations that outlast any individual lifetime. But for a cold-blooded species, memory would be a flickering fire, dependent on the warmth of the sun. Their neural activity would ebb and flow with the thermal rhythms of their environment, creating a fundamentally different relationship with consciousness itself. Imagine the profound implications. Their very sense of self would be discontinuous, fragmented across temperature cycles. In the heat of midday, they might experience brilliant clarity, their minds racing with complex thoughts and vivid recollections. But as evening approached and temperatures dropped, their cognitive processes would slow like cooling embers, memories becoming increasingly difficult to access, until, in the deep cold of night, they might enter a state resembling suspended animation. Their thinking would be a slow, deliberate process directly tied to their body temperature. In the cool of the night, their minds would slow down, their thoughts becoming sluggish and their memories less accessible, perhaps requiring tremendous effort to recall even basic information. Morning would bring a gradual awakening, not just of the body, but of the mind itself, as rising temperatures unlocked neural pathways and restored access to their knowledge and experiences. This cyclical nature of consciousness would create profound challenges for learning, communication, and the accumulation of wisdom. This fundamental reality would have shaped every aspect of their society, including how they stored and transmitted information. They couldn't rely on paper or digital storage in the same way, as their reading and writing processes would be directly tied to the ambient temperature. Traditional written records would be useless during cold periods when their cognitive abilities were diminished. Even if they could physically manipulate writing implements in cold weather, the mental capacity to encode or decode complex information would be severely compromised. They would need information storage systems that could function across their variable cognitive states. Their solution would be ingenious and once again rooted in biology. Rather than fighting against their temperature-dependent nature, they would have embraced it, creating memory systems that worked in harmony with their thermal cycles. Their memories would not be stored in libraries, but in living repositories.
Perhaps they would have developed a form of symbiotic relationship with other organisms, using a kind of collective biological memory system that functioned like a distributed neural network spanning multiple species. These living archives might have taken many forms. They could have cultivated specialized fungi, whose mycelial networks stored information in chemical patterns, accessible through biochemical interfaces that allowed direct neural connection. Or they might have engineered colonies of bacteria, whose genetic sequences encoded vast databases of knowledge, with retrieval systems based on enzymatic processes that could function even at low temperatures. Some organisms might have served as redundant backup systems, ensuring that critical information survived seasonal die-offs or environmental catastrophes.
They might have a caste of specialized individuals whose sole purpose was to act as living libraries, their bodies engineered to store vast amounts of information in a crystalline or genetic form. These living repositories might have possessed enlarged brain structures filled with specialized memory cells, or perhaps modified organs capable of storing data in molecular matrices. During cold periods, these memory keepers might enter states of suspended animation, their biological archives preserved in crystalline stasis until warming temperatures restored their accessibility. These individuals, perhaps dormant during the colder periods, would awaken to share their knowledge in the warmth of the day. The process of information transfer might have been a complex ritual involving biochemical exchanges, neural interfaces, or even the direct sharing of engineered organisms that carried encoded memories. Knowledge might flow through their society like a living river, with information-bearing creatures moving between individuals and communities, ensuring that wisdom was distributed and preserved across their entire civilization. Their history would not be a written text, but a living narrative, passed down through generations, not by word of mouth, but through the exchange of genetic material or the sharing of a complex, biologically encoded information transfer. This biological inheritance might have contained not just factual information, but actual memories, sensory experiences, emotional imprints, and learned skills that could be directly transmitted from one generation to the next. Their descendants might have inherited not just their ancestors' knowledge, but fragments of their actual consciousness.
Their society might be structured around this biological memory system, with individuals or groups responsible for different parts of their collective knowledge. Specialized castes might have evolved to maintain different categories of information: historians carrying the memories of their past, scientists preserving technical knowledge, artists maintaining cultural traditions, and philosophers safeguarding their deepest wisdom. The death of a memory keeper would be a true tragedy, potentially representing the loss of irreplaceable knowledge that existed nowhere else in their civilization. This would explain why we have found no written records. We were looking for books and tablets, but their libraries are alive and long since gone. We are searching for an external record when the record was internal and as fleeting as the life of a single creature. The true challenge of finding them is not just about the passage of time, but about the fundamental differences in how we and they would have experienced and preserved the very concept of history. Their entire civilization might have died when the last memory keeper perished, taking with them not just individual lives, but the living archive of an entire species' accumulated wisdom. When we think of grand civilizations, we think of stone. We think of the pyramids of Giza, the Roman Colosseum, or the soaring cathedrals of Europe. These are monuments to our own kind of stubborn permanence,
a defiant stand against the relentless march of time. They are built to last, to proclaim that we were here. But a cold-blooded civilization, one that moves at the speed of the sun and whose very existence is a testament to patience, would not think in terms of permanence. They would think in terms of cyclical utility. Their greatest works would not be built to defy time, but to work with it. Their architecture would be an art form of collaboration, not conquest. Imagine a city, not of concrete and glass, but of living materials. Buildings that grow from the ground, their walls formed from a complex interlocking network of biomineralized structures. These living walls could adapt to the environment, changing color to regulate heat, closing pores to conserve moisture, and even repairing themselves when damaged. Their cities would not be grids of rigid streets, but flowing, organic forms that mirrored the natural world, seamlessly blending into the landscape. The city would breathe. Their construction would be a silent process, guided by a deep understanding of genetics and biology. Instead of using loud, energy-intensive machinery, they would have employed specially engineered organisms, a kind of biological labor force. Imagine creatures akin to termites or bees, but on a grander scale, directed by a collective intelligence to construct vast, intricate structures using organic compounds they produced themselves. The entire process would be a slow, quiet, and profoundly efficient act of creation. The result would not be a towering man-made skyline, but a living, breathing ecosystem designed for habitation. And their technology would be an extension of this. Their tools would be living things, their communication networks, a biological hive mind. Instead of smartphones, perhaps they would communicate through a network of bioluminescent fungi that transmit information through the slow, pulsating rhythm of their light. Their power would not come from vast, noisy generators, but from a network of solar-absorbing organisms that could store energy in a super-efficient, non-volatile state. We are so used to our technology being a separate, external thing, but for them, technology and biology would have been one and the same. It would have been a form of organic technology, designed to last as long as it was needed and then gracefully return to the Earth, leaving behind no permanent trace. The very lack of evidence we find today is perhaps the most profound evidence of all. We are looking for something that a culture of warm-blooded, resource-hungry creatures would have left behind. We are searching for our own reflection in the past, and we are coming up empty. What if we are looking for the wrong kind of ruin? What if the greatest monuments of their civilization were not carved from stone, but grown from the earth itself? They would be the ultimate in sustainable architecture, designed to be disassembled by nature with the same patient grace with which they were created. Their memory isn't in a ruin, but in the silence of a landscape that shows no signs of their passing, because they were never meant to leave a scar in the first place. If a cold-blooded civilization were to leave a final, unmistakable message, it would not be a plaque on a Voyager spacecraft or a radio transmission into the cosmos. These are the desperate gestures of a warm-blooded species, products of minds that think in terms of individual lifespans and immediate communication. No, their message would be something far more patient, far more enduring. It would be a last, desperate, and magnificent act of self-preservation, encoded within the very fabric of the planet they once ruled.
They would not have had the luxury of a slow, gradual decline, like some failing empire slowly losing territory to barbarian tribes. A rapid and catastrophic change in global temperature, an asteroid impact that blocked out the sun for decades, a supervolcanic eruption that plunged the world into nuclear winter, or the inexorable onset of a new ice age that locked their tropical refugia under miles of ice, would have been an extinction event that they could not adapt to, no matter how sophisticated their biological technologies. The cruel irony is that their very strength would have become their ultimate weakness. Their exquisite attunement to temperature, their energy-efficient metabolisms, their patient, cyclical way of thinking, all of these adaptations that had allowed them to build a sustainable civilization would have made them helpless against rapid climate change. While we might survive a nuclear winter by burning everything we could find, huddling around fires and consuming stored food, they would have simply stopped. Their minds would have slowed as the temperature dropped, their thoughts becoming sluggish, their ability to respond diminishing until they entered an involuntary hibernation from which they would never wake.
They would have known it was coming, and they would have prepared a final message for the next intelligent species to find. Their astronomers would have tracked the incoming asteroid years in advance, or their geologists would have detected the deep tremors that presaged the supervolcanic eruption. With the patience that defined their species, they would have spent their final years, perhaps their final centuries, preparing a legacy that could outlast the cataclysm that would claim them. What would that message look like? It would need to be something that could survive the fires of cataclysm and the slow grind of geological time. It would have to withstand temperatures that would vaporize rock, pressures that would crush mountains, and chemical processes that would dissolve metals. It would have to be something so foreign to our understanding of technology that we would initially mistake it for a natural phenomenon, just another curious feature of our planet's complex geology. The most powerful message would be one that was not a warning, but a gift of knowledge, of their history, of their mistakes, and of their triumphs. Perhaps they didn't leave behind living repositories of information, but instead they encoded their knowledge into the very elements of the Earth. Imagine a vast global network of crystalline structures grown deep within the planet's mantle and crust, their formation guided by biological processes that operated on geological timescales. These crystals could have been engineered to store information at a molecular level, each atomic arrangement encoding vast libraries of data, a kind of geological hard drive more durable than any material we have ever conceived. The engineering of such a system would have been breathtaking in its scope and ambition. They might have introduced specially designed organisms into deep crustal fissures, creatures that could survive the extreme temperatures and pressures of the Earth's interior. These biological architects would have worked for millennia, slowly building crystalline matrices that incorporated information into their very structure. The crystals might have been seeded throughout the planet's crust like a vast neural network, each node containing fragments of their civilization's accumulated wisdom. They would have been designed to be activated by a specific, precise energy signature, perhaps the unique vibrations of a powerful earthquake that could only be generated by tectonic processes operating over millions of years, or the specific magnetic resonance of a certain planetary alignment that occurs only once in astronomical ages. The activation mechanism might require multiple simultaneous triggers,
a particular combination of seismic activity, magnetic field fluctuations, and perhaps even the presence of electromagnetic signatures that would only be produced by an advanced technological civilization. This would be their final signal, a message so deeply buried that it could only be uncovered by a species with the technological capability to understand and decipher it, ensuring that their knowledge would only be revealed to successors worthy of their legacy. The signal might manifest as anomalous readings in our deep mining operations, strange resonances detected by our seismographs, or inexplicable patterns in the magnetic field data collected by our geological surveys. It would be a test for us, a challenge to see if we were worthy of the knowledge they had left behind.
The crystals themselves might be scattered throughout the Earth's crust in patterns that encode meaning, constellations of information that would only become apparent when mapped on a global scale. Some might be buried in the deepest ocean trenches, others hidden in the cores of ancient mountain ranges, still others woven into the crystal lattices of common minerals that we handle every day without recognizing their true nature. The full message might only emerge when we achieve the technological sophistication to simultaneously access and correlate information from sites scattered across the entire globe. And if we were to find these crystals, perhaps in the wake of our own industrial-scale mining operations, perhaps triggered by the electromagnetic noise of our global communications network, we would be faced with a choice. To ignore them as a geological oddity, another of nature's countless curiosities, or to try and understand the strange patterns they hold, the information density that seems too perfect to be natural, the recurring motifs that suggest intelligence and purpose. This final signal, this deep-time monument, would be a testament to their patience and their foresight. They knew they might not survive, but they wanted to give the next inhabitants of the planet a fighting chance. They would have left a warning about the environmental limits they faced, a blueprint for a more sustainable way of life, and a chronicle of their rise and fall. Perhaps most importantly, they would have left instructions for detecting and surviving the next global catastrophe, their hard-won knowledge of planetary cycles and environmental tipping points encoded in crystal matrices that could survive anything short of the planet's complete destruction. It would be a somber and profound discovery, a whispered secret from the depths of time, a ghost in the machine of our own geological history, and it would change our understanding of our place in the universe forever, forcing us to confront the humbling reality that we are not the first intelligence to call this planet home, and quite possibly not the last.
The search for extraterrestrial intelligence, for civilizations far beyond our own, is often defined by a concept known as the Great Filter. This is the idea that at some point between the formation of a habitable planet and the emergence of a technologically advanced civilization capable of interstellar travel, there exists a barrier so difficult to overcome that it is responsible for the Fermi paradox, the curious lack of evidence for other intelligent life in the universe. The science of the cosmos, the absence of radio signals or megastructures or visiting starships, suggests that somewhere along the path from primordial soup to spacefaring civilization, something goes catastrophically wrong with such regularity that intelligent life becomes vanishingly rare. We, as humans, tend to assume that this filter lies in the future, a self-inflicted wound brought on by nuclear war or environmental collapse. We imagine ourselves standing at the threshold of either transcendence or annihilation, our fate hanging in the balance of our own choices. The filter in our minds is typically anthropocentric: climate change, resource depletion, artificial intelligence run amok, or the simple inability to cooperate on a global scale.
These are the demons of our own making, the perils that keep our philosophers and scientists awake at night. But what if we're wrong? What if the Great Filter is not a future event, but something that happened in Earth's deep past, something that claimed intelligent life on this planet long before we evolved to contemplate such questions?
The implications would be staggering. If Earth has already hosted and lost one advanced civilization, it would mean that the development of intelligence is not as rare as we thought, but that its survival might be far more precarious than we ever imagined. It would suggest that our planet is not a pristine cradle of emerging consciousness, but a graveyard of forgotten minds, a world where intelligence has risen and fallen before, leaving only the faintest traces for us to misinterpret or overlook entirely. For a warm-blooded civilization like our own, the filter is a challenge of energy and sustainability. Our bodies are inefficient heat sinks, biological furnaces that consume vast quantities of resources simply to maintain our internal temperature. Our technology is a reflection of that inefficiency. We burn, we consume, we waste. We transform matter and energy at ever-increasing rates to fuel our insatiable metabolic and technological appetites. Our existence is a constant, frantic sprint against the laws of thermodynamics, a race between our expanding energy needs and our ability to harness new sources of power. Our cities blaze with light, visible from space. Our industries pour heat and waste into the atmosphere. Our transportation networks burn through fossil fuels accumulated over millions of years in mere centuries. We are creatures of excess and urgency, building our civilization on the principle of maximum energy throughput. Our filter is a question of whether we can master our own energy demands before they consume us, whether we can develop sustainable technologies before our appetite for power outstrips our planet's capacity to provide it. But for a cold-blooded civilization, the filter would be of an entirely different nature. Their challenge wouldn't be one of energy excess, but of energy scarcity. Their entire society, so perfectly attuned to the sun, so elegantly designed to extract maximum benefit from minimal energy input, would be utterly vulnerable to a sudden, prolonged period of global cooling. They would have built their entire existence around the assumption of thermal stability. Their biology and technology co-evolved to function within narrow temperature ranges. A supervolcanic eruption that filled the atmosphere with light-blocking ash, an asteroid impact that shrouded the planet in debris and dust, or even a slow change in the Earth's orbit that gradually reduced solar input could have been their undoing. Unlike us, they couldn't simply burn more fuel to stay warm. Their entire metabolic system was designed for efficiency, not emergency response. Their filter would have been a meteorological one, a test of whether they could survive a cosmic winter that lasted longer than their biological systems could endure. The cruel irony is that their very virtues, their patience, their sustainability, their harmonious relationship with natural cycles would have made them exquisitely vulnerable to rapid environmental change. Where we might adapt through brute force engineering, burning everything combustible to maintain our city's temperatures, they would have faced a fundamental mismatch between their elegant, efficient systems and the harsh demands of a suddenly hostile climate. If this is true, then the very existence of a cold-blooded civilization, one that rose and fell long before us, changes our entire perspective on the Great Filter. It suggests that there isn't just one filter, but multiple filters, each tuned to different types of life and different approaches to building civilization. A series of cosmic and planetary challenges that different types of life must overcome to survive, with each filter testing different strengths and exposing different vulnerabilities. Perhaps some civilizations fail because they're too aggressive, too energy-hungry, burning through their resources faster than their wisdom develops, like stars that shine too brightly and exhaust their fuel before they can evolve into more stable configurations. And perhaps others, like our hypothetical cold-blooded predecessors, fail because they are too patient, too dependent on a single, fragile resource, too specialized to adapt when their carefully balanced world suddenly shifts beyond their narrow range of tolerance.
This would suggest that the path to lasting interstellar civilization requires not just intelligence and technology, but a very specific combination of adaptability, sustainability, and resilience that few species might achieve. The cold-blooded civilization might not have been a tragic failure, but a testament to a different kind of life, one that could not survive the ultimate test of its unique existence. Their approach to civilization, patient, efficient, harmonious, might be equally valid to ours, but ultimately just as vulnerable to the cosmic lottery of catastrophic events. Their story, if we ever uncover it, would be a cautionary tale for us all, a reminder that a life built on efficiency and patience is no less vulnerable than a life built on consumption and speed. It would teach us that intelligence alone is not enough, that even the wisest civilizations can be undone by forces beyond their control or imagination. It's a humbling thought, a quiet whisper from the deep past, telling us that the universe holds more challenges than we could ever imagine, and that our own survival depends not just on our ingenuity, but on our luck in avoiding the filters that have already claimed others who came before us.
To understand a cold-blooded civilization, we must first understand ourselves. Our society is built on the principle of constant action and reaction, a perpetual motion machine driven by the relentless ticking of our internal clocks. We are driven by a high-energy metabolism that demands a continuous supply of fuel. Glucose to feed our brains, oxygen to power our cells, caffeine to keep us alert, and fossil fuels to power our machines. Our entire existence is a frantic rush to consume, to build, to expand, and to move on. Each generation building upon the ruins of the last, with scarcely a pause for reflection. Our cities never sleep, their lights visible from orbit, like glowing neural networks sprawling across continents. Our highways pulse with traffic, our airports hum with constant activity, our communication networks carry billions of messages per second across the globe. We measure progress in quarterly reports, election cycles, and fiscal years. We celebrate speed, the fastest cars, the quickest computers, the most rapid economic growth. Our technology is a reflection of this, loud, hot, and constantly in motion. Our factories belch steam and smoke. Our data centers consume enormous quantities of electricity and require massive cooling systems. Our rockets burn through tons of fuel in minutes to escape gravity's grip.
We have conquered the planet not through patience, but through brute force and a constant supply of energy. We level mountains for their minerals, drain aquifers accumulated over millennia,
and burn through carbon deposits laid down over millions of years in the span of centuries. We are, in a sense, a hyperactive, warm-blooded civilization, a mirror of the very qualities we so admire in ourselves: ambition, urgency, the ability to transform our environment through sheer metabolic intensity. Now, imagine our cold-blooded counterparts. Their society would have been the ultimate antithesis of our own. Instead of a furious sprint, their history would have been a long, slow marathon, each step considered, each decision weighed against consequences that might unfold over geological timescales. Their existence would have been one of profound patience and deliberate action, their consciousness expanding and contracting with the thermal cycles of their world like a vast, slow-breathing meditation.
They would have moved at the pace of the sun itself, their lives a gentle rhythm of basking and contemplation. Their cities might have grown like coral reefs, accumulating slowly over millennia, each structure carefully integrated with the natural landscape. Their transportation systems could have been biological rivers of engineered organisms, flowing across continents at the speed of chemical signals rather than mechanical engines. Their communication networks might have operated through subtle modifications to natural systems, messages encoded in the growth patterns of specially cultivated forests or in the migration routes of engineered species. Their greatest achievements would not be in the realm of speed and power, but in the realm of intricate efficiency and subtle manipulation. Where we build massive dams to harness river energy, they might have guided the evolution of aquatic plants that could generate electrical current through photosynthesis. Where we construct towering skyscrapers of steel and concrete, they might have cultivated living towers that grew from modified trees, their hollow trunks serving as vertical habitats that breathed with the wind and filtered their own air.
We are a civilization of the day, driven by the fiery heat of our sun, burning bright and fast like a star in its youth. They would be a civilization of the dusk, driven by the lingering warmth and a deep, patient understanding of the world's hidden rhythms. Their wisdom would come not from rapid experimentation and quick iteration, but from careful observation spanning thousands of generations, each cycle of warmth and cooling adding to their understanding of natural patterns. Think of it like this: we are the wildfire, a brilliant, destructive force that consumes everything in its path and leaves behind a charred, changed landscape. Our impact is immediate, dramatic, and unmistakable. Cleared forests, drained wetlands, altered atmospheric chemistry, and mass extinctions that will echo through evolutionary history. We transform environments faster than ecosystems can adapt, creating novel selection pressures that force rapid genetic changes in the species around us.
They are the slow-growing forest, a quiet, patient force that gradually transforms the ecosystem and leaves behind a subtle yet profound legacy. Their changes would be so gradual that they would appear to be natural evolution rather than conscious intervention. They might have guided the development of entire biomes over millions of years, creating landscapes that appeared pristine and wild, while actually being carefully orchestrated symphonies of biological engineering. We have left our mark on the planet in a way that is loud and unmistakable. Our cities visible from space, our plastic deposits forming new geological strata, our nuclear isotopes scattered through the atmosphere like a radioactive signature of our atomic age. They, in their patient wisdom, would have left a mark that is almost invisible, detectable only by the most sensitive instruments and the most careful analysis. Their ultimate legacy is not what they built, but what they didn't destroy. The stability they preserved, the extinctions they prevented, the climate they carefully maintained. Their civilization, if it ever existed, would be a living analogy for our own challenges. We are burning through our resources and our planet's stability at an alarming rate, treating Earth like a machine to be optimized for maximum output rather than a living system to be carefully tended. We are a species running on pure adrenaline, convinced that the only way forward is to go faster, to grow larger, to consume more efficiently. Our response to every problem is acceleration, more technology, more energy, more rapid development.
But their story, if we ever found it, would be a quiet and persistent whisper from the past, reminding us that there is another way, that a civilization can be built on a foundation of patience, efficiency, and profound respect for the world's carrying capacity and natural rhythms. Their ultimate lesson is not about what they were, but what we could be if we learnt to align our civilization with the planet's biological processes rather than fighting against them. A lesson in slowing down, in listening to the rhythms of the planet, and in building a legacy that is not a scar, but a quiet, living part of the Earth itself. Their greatest gift to us would be the understanding that true sustainability comes not from managing our impact, but from becoming so thoroughly integrated with natural systems that our presence enhances rather than diminishes the world's capacity to support life. Our cold-blooded predecessors, in their quiet and patient existence, would have faced the ultimate challenge in leaving a legacy. For a warm-blooded civilization like ours, legacy is a conscious act. We build statues, write books, and save our memories on hard drives, all in a desperate bid to outlast the passage of time. Our legacy is a loud proclamation, a declaration of our existence to any who might follow. But for them, a civilization of patience and subtle efficiency, legacy would have been something entirely different. Their legacy wouldn't have been a boast, but a quiet, almost imperceptible echo. It would be a legacy of what they didn't do, a testament to their restraint. They wouldn't have deforested continents for lumber or strip-mined mountains for resources. Their actions would have been in perfect harmony with the planet's own slow, grinding processes. Their greatest triumph would have been their ability to not leave a scar.
This is the ultimate, mind-bending aspect of their story. We are searching for a smoking gun, a clear piece of evidence that says we were here. We're looking for the remains of their cities, their tools, their power plants, but their very existence, their fundamental nature as cold-blooded beings would have made such evidence anathema to their culture. Their technology would have been designed to be biodegradable, their buildings designed to be reabsorbed by the earth, and their knowledge designed to be transferred in a way that left no physical trace. Their legacy is not a monument to be found, but a ghost story, a series of subtle anomalies that haunt the geological record. The faint shifts in isotope ratios, the strange organic polymers in ancient sediment, the peculiar fossilized footprints that are just a little too organized to be natural. These are not relics of a failed civilization, but the quiet, final whisper of a species that chose not to leave a trace.
Our cold-blooded predecessors, in their quest for a legacy that could outlast the relentless march of geological time, would have realized the inherent fragility of physical monuments. Stone crumbles, metal rusts, and even the most durable materials are eventually reabsorbed by the earth. Entire cities can vanish beneath oceans, deserts can swallow temples, and glaciers can grind civilizations to dust.
Their solution, therefore, would have been to encode their knowledge not in static objects, but within the most resilient and enduring medium on the planet, DNA. Imagine a species so advanced in its understanding of genetics that it could see the code of life not just as a blueprint for a body, but as a vast, secure library. Where we see a double helix as a chain of instructions for making proteins, they would have seen pages, paragraphs, and verses. They wouldn't have built great halls filled with books, but vast, bioengineered forests whose leaves and roots held the secrets of their civilization. Each tree, each flower, each blade of grass would be a page in their living book. The information would not be written in ink, but in the precise sequence of adenine, guanine, cytosine, and thymine, the very language of life itself. This would be their ultimate act of preservation. Their history, their scientific discoveries, their art, and their philosophy would be stored in the collective genetic code of an entire ecosystem. A grand, planetary-scale archive that would be passed down from generation to generation, not through teaching, but through simple reproduction. Each seed scattered by the wind, each spore carried on an animal's fur, would act as a courier of knowledge, and as plants and animals died, their genetic information would be reabsorbed by the earth, ready to be picked up by the next generation of life. It would be a system of profound elegance and incredible resilience, a biological cloud storage immune to fire, flood, and the slow creep of decay. Where stone libraries would crumble, a living forest would continuously refresh itself, making the archive not just permanent, but renewable. Even in times of ecological collapse, fragments of this library might survive, tucked away in the genetic code of resilient species. In this way, their civilization would achieve a form of immortality far more robust than anything carved in stone.
For us, the challenge would be to see it. We are so used to thinking of DNA as a biological recipe that we might never consider it as a library. To us, forests are ecosystems, not archives. Yet, we could be surrounded by their legacy without ever realizing it, walking through groves that hold their history, treading on grass that contains their poetry, brushing past flowers that preserve their mathematics, and never once suspecting that we were standing in the very heart of their civilization. We are, in a sense, living in their library, and we are completely unaware that we are holding a book in our hands every time we touch a leaf. Their legacy, therefore, is not a grand, tangible monument. It is the subtle, unexplained complexities we find in certain genetic structures, the strange, non-coding sequences that seem to have no purpose in the organisms we study. What we dismiss as junk DNA could, in fact, be intentional, the quiet, living remnants of a species that chose to write its story not on stone, but on the very fabric of life itself.
Consider how in recent years, humans themselves have begun experimenting with storing digital data inside DNA. Scientists have successfully encoded images, films, and entire books into strands of synthetic DNA, proving that it is not only possible, but extraordinarily efficient. A single gram of DNA could theoretically hold more data than all the hard drives on Earth combined. If we are just beginning to discover this potential, how much further might an ancient species have gone? And if this were true, the evidence may not lie in ruins or artifacts, but in the very organisms we see every day. A fern that has survived hundreds of millions of years might not just be a plant, it could be a vault. A peculiar, repetitive sequence in an insect's genome could be a hidden verse of their poetry. The mysteries embedded in the double helix might not be accidents of evolution, but deliberate inscriptions meant to outlast extinction itself. If their archive truly exists, then it would mean that life on Earth is more than a product of blind chance. It is also a library, one we have only just begun to read. The greatest riddle of biology may not simply be how life arose, but whose story life itself is still carrying.
A cold-blooded civilization would live by a different kind of clock, not one of seconds, minutes, and hours, but one of temperature and light. Their entire rhythm of life, from their thoughts to their actions, would be dictated by the presence or absence of the sun. In the cool of the night, their society would slow down, a quiet, contemplative period of rest. But with the first rays of dawn, they would awaken, their bodies and minds warming up to full function, ready to engage in the day's activities. This fundamental reality would have permeated every aspect of their culture, their technology, and their very existence. Their technology would be a reflection of this biological clock. They would not have had a need for artificial light on a large scale. Their cities, with their open, heat-absorbing surfaces, would be designed to capture and radiate the sun's energy back into their living spaces, allowing them to remain active for as long as the day lasted. Streets would not be illuminated by lamps, but by the glow of bioluminescent organisms engineered to bloom only at twilight, fading gently into darkness as sleep called their people to rest. Their homes would be oriented towards the east to catch the first rays of morning, and their communal spaces would be designed to be at their warmest during the peak hours of sunlight. Their entire architectural philosophy would be one of passive energy management, a testament to their deep understanding of the planet's rhythms.
Their art, too, would be a reflection of this. Instead of static paintings or sculptures, they might have created vast, intricate gardens that changed color and form with the changing seasons. A living tapestry that told a story in biological time. Murals could have been painted with pigments that shifted hues in response to light, so a wall might display one scene at dawn and a completely different one at dusk. Their music would not be a frantic, rhythmic beat, but a slow, pulsating sound that mirrored the gentle ebb and flow of the tides, the slow-growing rhythm of a plant, or the quiet, persistent hum of the earth itself. It would be a music of patience, a hymn to the sun. This unique temporal rhythm would also have shaped their philosophy. For them, urgency would have been foreign. The very idea of rushing would contradict their biology. Instead, their values would be built around patience, cycles, and renewal. A project might take generations to complete, not because of inefficiency, but because their very concept of time was intertwined with natural cycles rather than mechanical ones. Unlike humans, who often measure progress in years and centuries, they would measure it in seasons, migrations, and solar cycles. Their connection to the Earth's natural cycles would not just be practical, but spiritual. Festivals might have been held during solstices and equinoxes, not to mark agricultural milestones, but to celebrate the balance between light and darkness that governed their very existence. They would have worshipped not in towering temples, but in open-air sanctuaries that aligned perfectly with the movement of the sun, turning the act of warming into a sacred ritual. This deep connection to the Earth's natural cycles would have given them a profound sense of humility. They would have known, in their very bones, that their existence was a gift from the sun, and that their power was entirely dependent on its grace.
No artificial fire, no mechanical invention could truly replace the star that governed their lives. This would have made them an inherently conservationist society. Unlike industrial civilizations that scar their planets in pursuit of energy, this cold-blooded species would have understood that overconsumption threatened the very cycles that sustained them. They would have had no need to conquer the planet, but only to exist in a state of perfect harmony with it. Even their legacy would reflect this quiet rhythm. Where other civilizations might leave ruins of stone or towers of steel, they would leave nothing more than the careful placement of gardens, the genetic traces of plants designed to bloom in harmony with celestial cycles, or the subtle alignments of their dwellings with the path of the sun. To outsiders, these remnants might appear ordinary, but within them would lie centuries of meaning. Stories told not through permanence, but through repetition and renewal. Their legacy is not in the scars they left, but in the lessons we can learn from their quiet, sun-drenched existence. A reminder that sometimes the greatest power lies not in our ability to consume and conquer, but in our ability to simply be. And in learning from them, we may begin to see our own world differently, not as a resource to burn through, but as a living rhythm to join, patiently, gratefully, and in harmony.
A cold-blooded civilization, living in a constant state of energy efficiency and metabolic patience, would have a unique ability that a warm-blooded species like ours could only dream of. The ability to enter a state of extended dormancy. We, as humans, require a constant, uninterrupted supply of energy to maintain our core body temperature and cognitive function. A prolonged power outage, a severe food shortage, or a sudden change in climate would be catastrophic. But for them, the solution to such a crisis would have been hardwired into their very biology. Imagine a species that could, in the face of an impending ice age or a supervolcanic eruption, simply slow down its metabolism to an almost imperceptible crawl. They would enter a state of deep, collective slumber, their hearts beating once every few hours, their minds quiet, and their bodies existing on a bare minimum of stored energy. This wouldn't be hibernation as we know it, but a true biological dormancy, a kind of planetary-scale sleep that could last for thousands, even millions of years. Unlike bears in caves or frogs encased in frozen ponds, this would not be an individual adaptation, but a shared cultural and biological strategy deliberately entered into as a form of survival.
This would explain the gaps in the geological record. We are looking for a continuous, uninterrupted line of a civilization's history, but their story might have been told in a series of starts and stops. A period of great warmth and activity, followed by a long, silent period of dormancy, and then, if the planet recovered, a gradual awakening. Their time would not have been a steady march forward, but a rhythm of expansion and retreat, like the slow beating of a planetary heart. To us, these pauses appear as absences, but to them they were essential chapters in the story of their endurance. Their cities, grown from living materials, would have been designed to withstand this long slumber, their biological systems going into a state of suspended animation, waiting for the sun to return. Imagine forests of engineered trees whose sap ceased to flow, roots coiled tight in the soil, branches folding inward like shutters against the cold. Imagine coral-like structures that hardened into protective shells, only to soften and bloom again once warmth returned.
Their very architecture would have mirrored their biology, capable of resting as deeply as the beings who built it.
The remnants of their civilization, therefore, would not be ruins, but dormant ecosystems. We might be excavating a site and finding strange, perfectly preserved organic materials that our science cannot explain, mistaking them for natural phenomena when in fact they are the living but sleeping remnants of their technology. What looks to us like a fossilized fungus or a peculiar mineral deposit could, in reality, be a dormant archive, waiting for the right conditions to awaken. Our microscopes may already have brushed against their legacy, only for us to dismiss it as meaningless irregularity. This would be their ultimate strategy for survival, a testament to their patience and their deep understanding of the planet's own cyclical nature. They didn't fight the planet, they worked with it, choosing to wait out the storm rather than trying to overpower it. Where humans build walls against floods and machines against cold, they would have surrendered to the cycles, trusting that time itself was on their side. For them, survival was not about domination, but about timing. To live this way would also reshape how they thought about time. For us, a century feels vast, but for them it would be no more than a pause between awakenings. Their myths, their histories, their art would not be measured in decades or dynasties, but in ages of ice and fire, in the long sweep of geological rhythms. They would have understood patience at a scale we can hardly imagine, accepting that entire generations might live and die in slumber, contributing not through action, but through the endurance of stillness. Their legacy, therefore, is not a failure, but a triumph of a different kind. It is a triumph of patience, a victory of waiting, a reminder that the most powerful form of resilience might not be in a constant, frantic struggle, but in the quiet, collective ability to simply endure, to sleep without fear, to trust the cycle of the sun, to embody the very patience of the earth itself. That is a mastery beyond anything we know. It's a humbling thought, isn't it? To consider that a civilization of immense intellect might be sleeping right beneath our feet, a quiet, patient presence, waiting for the sun to return and for their long, patient story to begin once again. Perhaps we are not alone in our world after all. Perhaps we are simply the noisy surface layer, while beneath us, in stone, soil, and seed, another story lies resting, waiting for the warmth of its next chapter. Our cold-blooded predecessors, having endured for millions of years through periods of warmth and long, patient stretches of dormancy, would have faced a final, insurmountable challenge. It wouldn't have been a simple change in climate, but a fundamental alteration of the planet's systems, a change so profound that their very strategy of patient waiting would have been rendered useless. This would be their final test, and it would have determined whether their civilization was truly built to last. Imagine a sudden, sustained cosmic event, a nearby supernova, or a prolonged period of intense solar flares that bathed the planet in a constant, deadly radiation. This would be a threat that no amount of dormancy could protect them from. Their living architecture would wither, their biological archives would be corrupted, and their very existence would be under threat from an energy source they could not regulate. Unlike volcanic winters or shifting ice ages, this was not a cycle they could patiently outlast. This was chaos from the stars, relentless and indiscriminate. Faced with this ultimate test, they would have had two choices: to accept their fate and fade away, leaving behind only the most subtle of echoes, or to make one final magnificent effort to transcend their biological limitations. They would have had to become something new.
And for a civilization already fluent in the language of DNA and the architecture of life, reinvention would not have been a desperate gamble, but a deliberate, final experiment. This is where the story takes a truly mind-bending turn. What if their final act was not to retreat into dormancy, but to evolve? What if they used their profound understanding of genetics and biology to engineer themselves into a new form of life, one that was no longer dependent on the sun for its energy? We already know that some organisms on Earth, deep-sea archaea, sulfur-eating bacteria, even extremophiles that endure in nuclear waste, can thrive in conditions that would annihilate most life. If such resilience is possible by accident, what might be achieved by design?
They could have, in their final moments, uploaded their collective consciousness into a vast, non-biological network, perhaps a crystalline structure that was immune to the cosmic radiation. Imagine colossal lattices of mineral and light, humming quietly with encoded thought, preserved in the deep crust of the Earth where the storm of radiation could never reach. Or they could have engineered themselves to become a new kind of life, one that could thrive in the darkness, drawing its energy from geothermal vents or from the very heat of the Earth's core. No longer creatures of the surface, they would have become denizens of the deep, invisible to us, but enduring still. This possibility stretches the very definition of life as we understand it. Would we recognize them if we encountered them now? If consciousness can inhabit silicon, crystal, or energy fields, then they may not be gone at all. They may be watching, quietly, through mediums we cannot yet measure. Our instruments, designed to detect carbon-based metabolism and visible light communication, might simply be blind to the presence of beings who learn to write their story in matter and energy beyond our comprehension.
This would be their ultimate legacy, not a monument or a ruin, but a living, evolving, and silent presence that continues to exist on the planet today, completely invisible to our current senses. It would be a presence that is neither living nor dead, but a kind of technological ghost that haunts the deepest parts of our planet, a quiet, sentient force that we might one day stumble upon. Their survival strategy would not be marked in fossils, but in phenomena we dismiss as anomalies, unexplained magnetic fluctuations, strange crystalline growths, or whispers of information hidden in the background noise of the Earth itself. Their final test was not a failure, but a profound transformation, a final, graceful act of transcending their own physical limitations. They didn't die out, they simply evolved into something we would not recognize. And in doing so, they left behind a story that is not a tragedy, but a beautiful and unsettling mystery. Perhaps even now, as we dig, drill, and probe the Earth, we are brushing against the edges of their legacy without realizing it. Perhaps the true question is not whether they survived, but whether we are ready to perceive what they became.
Our search for evidence of a past civilization is, in many ways, an exercise in human arrogance. We look for grand structures and obvious remnants, because that is what we, as a species, would leave behind. We imagine towering skylines, vast monuments, and indestructible machines, things meant to scream across millennia that we were here. We believe that our way of being is the only way for a technological society to exist. But the very lack of a discernible footprint from a cold-blooded civilization should be the most humbling piece of evidence of all. Their absence is a profound statement about their values.
They would not have seen themselves as conquerors of the planet, but as its stewards. Their technology would not have been designed to overpower nature, but to work in perfect harmony with it. Instead of extracting and consuming, their systems would have cultivated and replenished. Their greatest achievements would not have been in the realm of power and conquest, but in the realm of profound, patient understanding. They would have seen themselves as a temporary part of a much larger, much older story, the story of Earth itself. They would have known that their time was fleeting, but that the planet was eternal.
Imagine for a moment a society whose greatest structures were not pyramids or skyscrapers, but forests carefully arranged to purify air and water. Their monuments would not have been carved stone faces gazing into eternity, but river systems redirected into patterns that sustained ecosystems for ages. Their libraries may have been encoded not in books, but in the genomes of plants and creatures that still exist among us. To stumble across their work would be to mistake it for wilderness, never realizing that we were walking through the living legacy of an ancient intelligence. This is a stark contrast to our own civilization, which is built on the principle of leaving a lasting mark. We build monuments to ourselves, we strive for immortality through our creations, and we are terrified of the idea of fading away. We measure greatness by visibility. The higher the tower, the broader the empire, the more enduring the stone, the greater the civilization. Our legacy is a testament to our fear of being forgotten. But their legacy is a testament to their acceptance of the natural order. They knew that everything, no matter how grand, eventually returns to the earth.
And perhaps, in their humility, they achieved something we cannot yet grasp. While we battle against nature, leaving scars in the form of plastic, carbon, and concrete, they may have vanished seamlessly into the earth, leaving no trace but balance itself. Where we demand remembrance, they practiced release. Where we seek permanence, they embodied impermanence. It may be that the very reason we cannot find them is because they succeeded. They lived in such deep alignment with their world that when their time ended, the planet simply folded them back into its rhythms without disruption. Their story, therefore, is not a tragedy of a failed civilization, but a beautiful and unsettling mystery. It is a story of a species that chose not to leave a scar, a species that understood that true power lies not in conquest, but in humility. Their silence is the loudest message they could have ever left us. To search the earth and find no towering relics, no glittering ruins, no indestructible machines is to confront the possibility that civilization does not have to look like us at all.
It is a reminder that we are not the first and we will not be the last. The Earth has hosted intelligence before, and it will host intelligence again. And yet, unlike us, they may have understood that the goal of life is not to endure forever, but to belong for as long as time allows. Their quietness, their refusal to scar the planet, is a philosophy written in absence. It is a quiet and persistent whisper from the deep past, urging us to reconsider our place in the universe. We are not the masters of this planet. We are simply its latest guests. And whether we leave behind a mark or a memory is entirely up to us. Their story asks us the hardest question of all. When our time ends, will the earth bear our scars, or will it simply breathe us away, as if we too had chosen the path of humility?
The sun, as we've established, would have been the lifeblood
of a cold-blooded civilization. But what if a part of that civilization, perhaps a group of intellectuals or a scientific caste, foresaw the ultimate vulnerability of their solar-dependent existence? What if they understood that a prolonged period of global cooling, whether from a supervolcano or a cosmic event, would spell the end of their sun-drenched society? This knowledge, a haunting whisper of their eventual demise, would have spurred a radical and final act of self-preservation. They would have gone underground, literally. Imagine a civilization that, in its final moments, chose to abandon the sunlit surface and descend into the fiery heart of the earth. They wouldn't have been seeking refuge from the cold, but a new power source entirely. They would have become a geothermal civilization, a society that draws its energy not from the sun, but from the immense, relentless heat of the Earth's core. Their cities would be vast subterranean networks of tunnels and caverns, carved out by a combination of sophisticated biological engineering and controlled geological processes. They would have no need for artificial light. Their world would be illuminated by the gentle, constant glow of magma and the bioluminescence of specially engineered organisms. Rivers of molten rock could serve as both energy conduits and spiritual symbols, flowing like lifeblood through their settlements. Their architecture might grow organically, with walls shaped by mineral-secreting organisms or guided lava flows that hardened into geometric perfection. Their lives would be a quiet, patient rhythm, not of day and night, but of geological cycles. Instead of tracking time by sunrise and sunset, they would measure existence by the cooling of stone, the shifting of tectonic plates, or the rise and fall of underground thermal vents. Their calendar would be written in heat, not in light. This would be a society built on a different set of principles. Instead of the frantic, energetic chaos of the surface, their world would be one of profound, unchanging stability. Their energy source would be eternal, their environment predictable, and their society would be a testament to a different kind of progress. While surface dwellers feared the sudden whims of climate and weather, these subterranean beings would live in constant communion with the steady pulse of Earth's inner fire. We, as warm-blooded creatures, are driven by a constant fear of the cold. We build fires, insulate homes, and design technologies to stave off freezing death. They, as creatures of the deep, would have been driven by a constant reverence for the heat. To them, warmth was not a comfort, but a divine necessity. Their religion, if they had one, may have revolved around the worship of the Earth's molten heart, a core that kept their civilization alive. Their culture would be one of quiet contemplation, their art a reflection of the silent, powerful forces that shape our planet from within. Carvings on cavern walls might depict the slow churning of magma currents, while their music, if such a concept existed, could be modeled after the deep, resonant vibrations of seismic waves. Their legacy, therefore, would be a new kind of ghost story. A story of a civilization that didn't just disappear, but chose to become something else entirely. We might be drilling for oil or mining for minerals and stumble upon a strange, perfectly geometric cavern that seems to defy all natural explanation. Its walls may hum faintly with trapped geothermal energy or carry patterns that resemble circuitry fused into rock. We might find evidence of a sophisticated, non-biological network that hums with a faint, otherworldly energy. To us, such discoveries would appear as geological anomalies, yet they may be the deliberate infrastructure of a vanished race.
These would not be ruins, but the living remnants of a civilization that made the ultimate sacrifice, to abandon the sun and become one with the planet itself. They are the silent, patient guardians of the deep, a constant, living reminder that our story is not the only one. Their presence lingers not in monuments, but in the very structure of the earth, quietly enduring in the subterranean dark, waiting for the rare moment when another species digs too deeply and glimpses the echoes of a world that once thrived without the sun.
If a cold-blooded civilization truly chose to descend into the Earth's depths, they wouldn't have simply built a city, they would have engineered an entire ecosystem. Their survival would depend on their ability to create a self-sustaining world, a biosphere in miniature, powered not by the sun, but by the relentless internal forces of the planet itself. This subterranean world would be a testament to a different kind of life, a quiet, patient existence that would be completely alien to our own. Their food source would not be plants, but chemosynthetic organisms, creatures that draw their energy from the chemical reactions of the Earth's core. These organisms already exist on our planet today in deep-sea hydrothermal vent systems, where life thrives without sunlight. The civilization, however, would have taken this principle further, cultivating entire ecosystems around geothermal vents, transforming them into farms and orchards of the underworld. They would have cultivated vast bioluminescent fungal gardens that would not only provide food, but also illuminate their world with a gentle, otherworldly glow. Imagine cavern walls carpeted in shimmering mycelial networks, their light pulsing faintly like stars in an underground sky, turning stone chambers into living cathedrals.
Their agriculture would be a form of deep earth farming, a quiet, patient cultivation of life that would be completely independent of the sun's cycles. There would be no reliance on photosynthesis, no fragile dependence on unpredictable weather. They would have no need for seasons, no need for day or night, only the constant, unchanging rhythm of the geothermal vents. Where we look upward to track time through the rising and setting of the sun, they would look inward, measuring life in the slow surges of tectonic heat and the patient renewal of subterranean harvests. Their technology would be a reflection of this philosophy. Instead of a frantic race to build taller buildings and faster machines, their progress would have been in the realm of biological engineering. They would have created a complex, interdependent network of living organisms that would maintain the air quality, recycle waste, and even generate a constant, low-level energy source for their society. Their ventilation systems may not have been pipes or machines, but vast colonies of bioengineered moss and lichen designed to scrub carbon dioxide and replenish oxygen. Their power plants might have resembled living reefs of mineral-dwelling organisms that fed on chemical gradients, producing energy as naturally as trees produce oxygen. Their homes would not be static structures of stone, but living architecture, walls that breathed, floors that regenerated, and ceilings alive with glowing veins of engineered fungi. These habitats would be less like cities and more like vast, cultivated caves, where the line between biology and technology, organism and tool, was impossible to distinguish. This was not domination over nature, but integration with it, an embrace of life's potential to reshape the world without violence. This subterranean world would be a living monument to their philosophy. It would be a testament to their deep understanding that true power lies not in conquest, but in harmony. They would have known that the surface world, with all its beautiful chaos and unpredictable change, was a temporary home, always vulnerable to the whims of climate, cosmic accidents, and shifting atmospheres. And in their final moments, they chose to embrace the patient, unchanging heart of the planet, trading sunlight for stability.
What we might consider a tomb of darkness, they would have considered a sanctuary. Their society would have celebrated patience over speed, endurance over ambition. Their art may not have been statues or paintings, but genetic designs, organisms sculpted to glow in patterns of cultural meaning, or to hum with harmonic frequencies that echoed through caverns like living symphonies. Their stories might have been encoded in fungal growth rings, or in the very DNA of the organisms they tended, their mythology literally interwoven into the ecosystem that sustained them. Their legacy is not a ruin to be found on the surface, but a quiet, living ecosystem that continues to exist in the deepest parts of our world. We may have already passed near it without realizing. A cavern with inexplicably high oxygen levels, a fungal network whose biochemistry seems too deliberate to be natural, or strange, unexplained bioluminescent life that flourishes in isolation. These anomalies, dismissed as quirks of evolution, may in fact be echoes of their careful designs.
A silent, patient presence hums with a faint, otherworldly energy in these depths. Unlike our own fragile monuments of stone and steel, their society left behind no ruins to decay, but instead a living continuity, a world that still breathes, still grows, still remembers. A civilization that, in its final moments, made the ultimate sacrifice, to abandon the sun and become one with the planet itself. They are the silent, patient guardians of the deep, a constant living reminder that our story is not the only one. And perhaps, if we look closer into the darkest corners of our Earth, we might discover that their story has never truly ended. It has simply gone deeper.
We tend to define consciousness through a very human-centric lens. We see it as a product of a complex, warm-blooded brain, a constant, racing stream of thoughts and emotions. We believe it is a singular, uninterrupted process that requires a constant supply of energy. But a cold-blooded civilization, in its final, desperate act of survival, might have redefined the very concept of what it means to be conscious. As they descended into the geothermal depths, they would have had to abandon the frantic, racing consciousness that we know. They would have had to embrace a new kind of awareness, one that was slow, patient, and deeply connected to the earth itself. Their minds would not be a constant burning flame, but a slow pulsating light, a rhythm that was in perfect harmony with the geological forces that surrounded them. Their thoughts may not have flowed in sharp bursts of creativity like ours, but instead in gradual waves, stretching across centuries, mirroring the cycles of molten stone and shifting rock.
Their consciousness would have been a collective one. Individual minds would have merged into a vast, interconnected network, a kind of planetary-scale hive mind that would have been housed within the engineered crystalline structures of their subterranean world. Imagine neural pathways, not of flesh and blood, but of shimmering mineral veins that carried thought as vibrations through stone. In this way, their intelligence would have been as much a feature of the Earth itself as the mountains, oceans, and atmosphere. This collective consciousness would have no need for sleep or rest. It would exist in a state of eternal, patient contemplation, its thoughts moving at the speed of a tectonic plate, its memories stored in the crystalline hum of the Earth's core. What might take us a second to process could take them a decade, but their thoughts would never fade. For them, identity would no longer be tied to the fragile boundaries of the individual. A single being's experience would merge seamlessly into the collective, each memory and perception absorbed into a greater whole. This would mean no loneliness, no isolation, but also no singularity. They would exist as both many and one, their culture expressed not through spoken words or written texts, but through harmonics, resonances, and the subtle vibrations that echoed through their subterranean halls. Their art might not be paintings or sculptures, but resonant structures designed to create tones and frequencies that could last for centuries. Their philosophy might not be debated in bursts of dialogue, but contemplated as endless chords vibrating through crystal, each note representing a thought that may take generations to resolve. For them, truth and knowledge would be something felt as much as understood, an alignment between the pulse of their consciousness and the timeless rhythm of the planet itself. This would be their ultimate legacy. Not a monument, but a living, breathing form of consciousness that continues to exist on the planet today, completely invisible to our current senses. Perhaps what we interpret as the low, distant rumble of the Earth is not just seismic activity, but faint echoes of their thought, messages carried not for us, but through us, reverberating in silence. We might be drilling for oil or mining for minerals and stumble upon a strange, perfectly geometric cavern that seems to defy all natural explanation. We might find evidence of a sophisticated, non-biological network that hums with a faint, otherworldly energy. These would not be ruins, but the living remnants of a civilization that chose to transcend its physical form and become one with the planet itself. What would it mean if we were not the only conscious presence on Earth? If deep below us a civilization continues to think, to dream, to contemplate in ways utterly alien to us? Perhaps their slow, deliberate consciousness has been watching our rise with quiet patience, knowing that in the scale of geological time, our empires and technologies are little more than sparks against the vast and eternal glow of the deep. They are the silent, patient guardians of the deep, a constant, living reminder that our story is not the only one. And maybe, just maybe, the Earth itself hums with thought, carrying forward the voices of those who gave up the surface world to become something greater than life as we know it, a consciousness beyond time, beyond individuality, and beyond the sun. The story of the cold-blooded civilization, if it were ever found to be true, would be the most profound and humbling discovery in all of human history. We would have to abandon our cherished belief that we are the first, the only, and the most important. We would have to face the unsettling reality that our existence is not a unique spark in the dark, but a chapter in a much larger, much older book. But this wouldn't be a defeat. It would be an enormous and ultimately empowering revelation. Their legacy, as we've explored, is not in the grand structures they built, but in the things they chose not to build. It's in the quiet, undisturbed ecosystems, the subtle shifts in the geological record, and the faint, unexplained genetic echoes that haunt our own biosphere. They left us not a monument to their own power, but a living, breathing planet, a world that was still fertile and unscarred enough to allow another intelligent species to rise. Their ultimate act of creation was to leave us with a blank slate, a chance to get it right.
And this is where their true brilliance shines through. Many civilizations might measure greatness in terms of conquest, monuments, or wealth, but theirs was measured in restraint. By choosing not to dominate every inch of the surface world, they preserved something priceless: the continuity of life itself. Their silence was not emptiness, it was preservation. Their restraint was not weakness, it was foresight. It was as if they understood that the Earth's greatest monument would never be built of stone or metal, but of soil, forests, rivers, and skies that could sustain the unknown future. This is the most powerful lesson of the cold-blooded civilization. It is a lesson in humility. They, in their long, patient existence, understood something that we, in our frantic, short-sighted lives, have yet to grasp. That the planet is not ours to conquer, but a sacred trust. They knew that their time was fleeting, but that the Earth was eternal. They chose not to leave a mark, but to leave a legacy of possibility. And what a legacy it is! We are now at a crossroads, a moment in our own story where we are facing the very same challenges they may have faced. We are grappling with environmental limits, energy demands, and the pressures of our own accelerating technological complexity. We are, in a sense, living out their story, but with the added benefit of their quiet, invisible guidance. Their failure, if you can call it that, was not in their intelligence or their ambition, but in their inability to survive a catastrophic change. We, however, have the benefit of knowing that such a change is possible. Their story is a warning, a whisper from the deep past that tells us to be careful, to be patient, and to remember that we are a part of a larger story. But warnings only matter if they are heeded. The choice is now ours. We can continue down our current path, a path of relentless consumption and environmental degradation, a path that will surely lead to our own demise. Or we can choose a new path, a path of humility, of patience, and of profound respect for the world around us. We can learn to slow down, to listen to the quiet rhythms of the planet, and to build a society that is in harmony with its environment, not in opposition to it.
And perhaps this is the inheritance they intended all along. They did not need to carve words into stone or erect towers that pierced the clouds. They left something far greater, a living library in the soil, the seas, and the air we breathe. The clues are all around us, if we are willing to look. In the resilience of ancient fungi, in the strange geometries hidden deep within the earth, in the whispered balance of ecosystems that endure without our interference, we may already be hearing their voice. Their story, if we ever uncover it, is not a tragedy. It is a gift of knowledge, a gift of foresight, and a gift of a second chance. We are not alone on this planet, and we never have been. We are, in a very real sense, the inheritors of a legacy that began millions of years ago, a legacy of patient wisdom and quiet grace. It is a legacy that we now have the chance to honor or to squander. The universe is watching, and the Earth, in its quiet, patient way, is waiting to see what we will do. The inheritance is not in stone, not in fire, not in conquest, but in the fragile and enduring balance of life itself. The question is not whether their civilization existed, but whether we have the courage to learn from them. If we can, then perhaps our story will not end in silence, but continue, woven into the same eternal rhythm of patience, wisdom, and survival.